box contains 7 yellow, so we'll write this down right away. 7 yellow, 3 green, 5 purple, and 6 red candies all jumbled together. Okay, so immediately I'm thinking, how many do we have all together? Well, 7 plus 3 is 10, 5 plus 6 is 11, so 10 and 11 is 21. Okay, so I get a total of 21. So what is the probability of receiving 4 red candies if you choose 6 from the box? So we're choosing 6, and we want 4 red. Okay, so we're going to have 2 groups. We're going to have one group is going to be red, and then the second group is going to be not red. So basically red complement. If you want to recall that, that'd be fantastic. So for A, the probability of exactly 4 being red, well, let's take a look. There are 6 red, and how many non-red? Well, out of 21, there would be 15 non-red. Okay, so red, which is 6, and not red, which is 15. So group 1, there are 6 red, and we're choosing 4, and there are 15 not red, and if we're choosing 6 altogether, there would be 2 more that we would choose. And it's all out of 21 candies, and we're choosing 6 of them. So this would be the probability of receiving 4 red candies if we choose 6. Now, B. What is the expected number of red candies among 5 candies that are poured from the box? Okay, so we just have to make sure that we read the entire question. Well, this is the intuitive way of doing it. Okay, how many red candies are there? There are 6 out of 21 red candies. So that's basically the probability that you choose red. Now, you're choosing 5 candies. So the expected number is 30 out of 21. And if you do the math, 30 divided by 21, 1.43. Okay, so you're expected to choose 1.43 red candies out of a possible 5 that you choose. Okay, now solve for the expected number of red candies among 5 candies poured from the box using the general equation for expectation, and what do you notice? So what we'll have to do for this one is we will have to take x and we'll have to take px, and then we're going to have to multiply them and then add them. So we would have to do the entire probability distribution. So if you're choosing 0 red candies, 1, 2, 3, 4, 5, or 6, and so you would do 6 choose 0 times 15 choose all of the 5, and then divide by 21 choose 6. And you would have to do that all the way down. So do this as an activity, this one, and then fill out the actual probability in like a decimal, and then fill out the XPX. Add it all at the bottom, see what you get. Basically, what this is trying to prove to you is that this 1.43 is the exact same thing as actually going through every single outcome in the probability distribution, and it's going to be the same thing. So this is just like a shortcut by using the formula. Now, example 3. 500 ducks were caught and tagged and released back into the wilderness. Okay, so there are 500 that are tagged. To estimate the population, 40 ducks were caught and 15 had tags. Okay, so 40 caught and 15 had tags. So determine whether this situation can be modeled with a hypergeometric distribution. So let's talk about this first. Okay, there are going to be 2 groups here. There are going to be tagged and not tagged. Tagged and not tagged. And every single time you choose one of the ducks, like you're going to keep it and then continuously choose more and more ducks, right? So this is dependent. So the probability of choosing a specific duck, is going to change when we choose the duck before it. It's going to change how many ducks are left to be chosen, how many tagged, how many not tagged. Okay? So it is hypergeometric. Now, estimate the duck population in the wilderness area. Here's the thing. 40 were caught, 15 had tags. So they're basically telling you the expected value. The expected number that is tagged is 15. Okay? And we don't know the population. So question mark, so X out of 500, sorry, flip that. 500 out of X. So 500 are tagged out of a total population. Now, and then times 40. So 40 is basically our N, like our number of trials, right? So we're catching 40. So all we have to do is cross multiply. So we get X equals 500 times 40 divided by 15. 500 times 40 divided by 15. I get 1, 3, 3, 3, and a third. Not decimal, and a third. So I get a population of 1,333, and there won't be a third on that because population won't have a third on it. But that would be the population of ducks in that area.